Hi everyone. Today we will discuss about how to simulate synthetic aperture radar using Ansys STK RFCM. RFCM stands for Radio Frequency Channel Modeler, which actually developed from solver, one of the solver from HFSS SBR Plus, which was mainly running on CPU, which was rewritten into GPU. So today we will create one scenario for Bangalore region, and let's create a Bangalore SAR and locate your folder. Click OK. So it will configure. So RFCM can be used for both for communication as well as for radar application. So we will show today the example of how to do the SAR simulation using STK RFCM. Once the project is configured, you can keep or generate SAR image of anywhere in the world. So first of all, what you need to do is you can see the globe. Some part is day, some part is night, depends on the time which you have selected. You can go to globe manager. You can see different these are the settings which enables this map loading into STK. First, let's add a place. Select from city database, insert, type Bangalore, insert it. Or did twice time, so delete, we can delete one. So here you can see the Bangalore. It will take some time to render it. Now you can see the Bangalore airport. It's called HAL airport in Bangalore. So we can zoom into that area. Now I can move that Bangalore place to exactly this location, edit it, and hold the shift key, press it. So now you can see this Bangalore location move to the HAL airport area. Next is we'll create a flight trajectory. Assume that there is an aircraft going to fly at some distance away from the Bangalore city, and that has a SAR sensor to that. So let's create a aircraft. Click insert, close. So there are different way we can create a trajectory. So great arc or aviator. Aviator allow you to create very high fidelity trajectory data with a 6 degree of freedom. In great arc, you will give a latitude, longitude, altitude, and speed of your aircraft. So we'll use a great arc for time being. So edit your aircraft. Click the. I can see when I clicking hold shift key and press it, you can see this trajectory is getting created. Once the trajectory is created, you do have an option to edit, remove if you want something, or if you want to move it, you can even move that one. So this trajectory actually determine the look angle of the SAR. So you have to decide which area or which trajectory path your aircraft is moving, and it is still valid for satellite. So you can have a LEO, GEO, MEO based satellite SAR imaging. Now we can we can zoom into that area. So this is a flight path. If I zoom into aircraft, you can see an aircraft which is flying through that trajectory path wherever Bangalore location you can see in the bottom. Now, next thing is if I want to edit this one, you can click edit, move little bit. So this actually determine the look angle as I mentioned. So here you can see the latitude, longitude, altitude, and speed of the vehicle, the aircraft. If you want to change anything, for example, I want to change the altitude to 7 kilometer and speed of the aircraft I want to change to kilometer per hour to 500 kilometer. Click OK. So everything going to change. So altitude of aircraft is changed now. So this is the aircraft which is going to fly. Now I wanted to add a sensor. A sensor is nothing but a gimbal or something which is going to attach with my aircraft. So I want to attach my sensor with the aircraft. Click OK. So this is having a coverage of 45° by default. So we'll edit it. Let's use 1°. And there is an option. It is currently looking towards the bottom. I can ask target to one particular area, which is nothing but Bangalore. Click apply. OK. Now you can see the sensor is looking from the aircraft to the Bangalore airport. Now if I animate my scene, you can see the aircraft is going, but at the same time the sensor is always looking towards Bangalore airport area. Next, what we need to do is we need to import the terrain as well as the building in that area, especially to the Bangalore trajectory. We are going to import the terrain, and to import the terrain we are using CCM Ion. You can log into CCM Ion using your private or personal email ID. There is a free version and a commercial version available. So first thing you need to do is you need to go to asset depot, where they will give what all the terrain, image, and 3D tiles. 3D tiles is mainly the building informations are available in the CCM. So which one you have seen the plus, you can download. You can see the photorealistic 3D tiles from Google, CCM moon terrains. There are images, you can import it. So the Washington State, some particular area, you may get very high fidelity terrain details from CCM. So what you need to do is you click the plus button. It will get asset added to my asset. Now you can see my asset has CCM moon terrain, Japan 3D building, aerometric, and others, so on. So this is the terrain which is added into my asset. Once you have these assets are added, you go to clip. So you just have to log in with your email ID and go to clip. First, what I need to do is I will create a terrain import. So click create clip, select whether you need a 3D or imagery and terrain. Select clip imagery and terrain. Next, from the asset which I have, it will list down which all imagery and terrain you can use it. So I'm using Sentinel-2 image and CCM world terrain. Click next, it will ask where is your latitude longitude location to be captured. So go to the search Bangalore. So Bengaluru, India. So it will come here, zoom into that location. So you will be able to see here is our HL airport. Now once you zoom in, you double click, you can select that area. So this is my terrain going to be. So up to 25 kilometers square area you can download without any subscription, but more than that you need to have a subscription. So import as a 3D tile set, create a clip, just give a name before that. Now you can go to your clips, you will see that it is getting added. So you can see Bangalore terrain is in progress. Within few couple of seconds it will get added. So like that I had to created the terrain for different area. So this is whole has a 3.77 MB size. What you need to do is you can just click the download button, it will get downloaded. Next, this is a zip file. We can copy that zip file into our folder location and paste it here. Extract all. Yeah. So what you will see is one JSON file and a lot of GLB file inside the terrain file. So this JSON file is actually pointing to all the GLB CAD data of the terrain, then form that particular area. So STK can consume this JSON file without any modification. So which region and what is the GLB you need to fix it. That's what it has. Now go back here. Let's add that terrain. Click add 3D tiles set. Go to the location where we saw or copied that files. So it's inside Bangalore. Click OK. Now you can see the Bangalore terrain is here. Click add. Now you'll be able to see on the left side Bangalore terrain is added. You can just right click, zoom to. The highlighted portion is nothing but the tile set which we added from the C ship. You can on and off toggle it and see how it is. You see this, the moment I disable CCM world terrain, the Bangalore location is 900 meter above the sea level. That's the reason it is elevated. So once you add proper terrain, it will match properly. Now let's go back to the session and create a 3D tile set. So in 3D tile set, you can select the from your asset, it will all get listed. And click next, similar to earlier, Bangalore. And this is mainly to download the building and other things which is in that Bang HL airport area. So select that area. You can see these buildings are getting highlighted. So I'm going to select this much of area, around 12 kilometer square area. That is fine, and click next. And tell that this is Bangalore buildings. Create a clip. So we are taking terrain and building separately because we can add different material property to these objects. Now that is downloaded, go here. Paste into our folder. Unzip it. I can delete that zip files. Now go back to my add 3D tile set. Now you can see the building also listing. Add it. If we zoom into that, you will be able to see the 3D buildings are also going to pop up. Now my Bangalore terrain, buildings, everything is ready. Next, what I need to do is I need to place some object for SAR imaging. For example, let's assume there is an aircraft which is on the runway. To add that object, we can create aircraft. Since I'm assuming my aircraft is not moving, so I'm selecting a facility. And in the facility, if I click OK, it will have a CAD associated with that. Yeah, before that we need to move that facility to this location. So we kept the facility at this location. You can see a runway right now having a building. We'll replace this building with an aircraft model. So a lot of aircraft models are available. So go to model, change the facility. It should be a GLB file. So you can use either a space claim or a blender for creating this CAD model. So any model can be exported into this format. So we are going to take an aircraft model. There are a list of models are available. You can choose one of it. So we'll use a C-130 Hercules aircraft for the time being. Click apply. Okay, now you can see the aircraft is there, but the aircraft is a little bit low below under the terrain. So what you need to do is you need to make a little bit up. Let's move 5 meters above the current position. Now you can see this aircraft is here, which is on the runway. Replace this with a C-130. So just for a better understanding. I can take a copy of it. I can say Control C, Control V. Now I have a two model. One is CE-130. Next one I can replace with some helicopter model. You can see a big air C-130 and helicopter is placed. Save the project. It's to be done periodically. Now let's go to utilities and select RFCM utility. You can see that aircraft with the sensor loaded is listed here. So select and then tell what kind of analysis you are going to do. So select the sensor, then the plus button is enabled. So as I mentioned, communication radar can be done. So select the radar and say this is my TX and RX. So this assume my antenna is a transmitter and receiver antenna. If somebody want to have a polarimetric sensor, you can add one sensor for TX and one sensor for RX. So you can choose a parametric antenna, select vertical, horizontal, RCP, LHCP, set the polarization. In another way, you can also have an option to use far field data pattern. The far field data pattern, your installed antenna pattern from HFSS or measured pattern can be used. So it will give better accurate SAR imaging. So you can tell what's the frequency at which your sensor going to operate, what is the maximum bandwidth of your sensor can support. So these are the information you need to provide here. Once that is done, you can click OK or apply. Go to analysis. What kind of analysis you are going to do? I'm going to do the analysis of radar. So radar SAR and ISAR can be done, and either I can also do the communication analysis between TX and RX in a multipath environment. Let's select SAR and tell Bangalore SAR. Click OK. Add plus button. Select your sensor TX and RX. Transceiver. So you can choose whether it is a transmitter only or transmitter receiver both together. So we'll use a single TX and a single antenna for both TX and RX. You choose which location you want to create an image. So click plus button, click the other button, go to your 3D graphics, zoom into the area where you want, and select the area where you would like to have a image. So that's the area. The center of that area will latitude, longitude will be assigned to that imaging location. So go back here, just select the image, click apply. You are done. Now this is your latitude, longitude. Scene contributor objects. So I have a C-130 and one helicopter. So I'll add these two into my scene contributor. So these are the objects which I am going to consider for my simulation. So I have only few listed material property in this. For that, if I want to add more material property, there is an option. So go back to my folder. So this one JSON file, I'll show you what is there inside. Copy paste into the scenario folder. So I'm going to copy paste the where the scenario file is located. So if I right click, you will see there are glass material. It is a dielectric. The first element is showing what's the thickness of the dielectric. 4 mm, 6.5 is dielectric constant. Imaginary part of dielectric constant, permeability, imaginary permeability, and conductivity. And the other side of the glass is a vacuum. That's what it's mentioned. Same way, you can see somewhere it is -1 indicating the infinite thickness, especially for terrain and other thing will have infinite thickness. Only the reflected rays will be computed. So you can have your own material property edited like this, and just keep the JSON file in the same format in your folder. Once this file is kept, what you need to do is you need to save the project and reopen it. Save, yes. It will get closed and reopen. Once the file is reopened, you go to scene contributor. Now if you see, all the material listed in the JSON will appear. So you can assign different material property to that. And then you can see I'm assigning the ray focused ray density that it determine how much ray it has to hit on that object. It is operation, that number is connected with the operating frequency of your radar. For example, it's in 10 gigahertz. Your ray density 1 means every lambda, so every 3 centimeter you will get a hit. If it is a ray density 2, that means every 1.5 centimeter on the CAD you are going to hit the ray. So you can also assign the ray density for the global. So ray density is 0.5. That means every 6 centimeter on the terrain you will have a ray hit. That's mainly to set your GPU memory consumption, and you can also set the number of reflection and transmission in the to be considered by the shooting and bouncing ray solver. So assign your material property, and now under the facet you can say Bangalore terrain. I'm going to use custom asphalt material, and Bangalore buildings I'm going to use some concrete material. Go to analysis time, so I can tell my analysis time, the computation to be done from 0 to some 100 seconds every 5 seconds interval. So this is the time the GPU going to run in the scenario and find the result. Here you can set your SAR imaging. So I wanted to create 500 by 500 meter SAR with the range resolution. So based on your input, the bandwidth, everything will set automatically. So let's say I am going to use 0.5 megahertz band, 0.5 meter resolution bandwidth, resolution in range and cross range. So that requires 300 megahertz bandwidth from the radar. So once you set, you can set the imaging with what kind of a window function you need to use. If you want to create imaging products graphics, that's mainly on the scenario, you can visualize that. If you want to create a gridding on it, you can enable. Where you want to create that image on the scenario, that's a 200 meter away from the CAD or this scene. Set everything and keep it transient auto. We can change it if needed. Click apply. Incomplete configuration. Okay, that means I didn't select the extent. So we have that 12 kilometer or 14 kilometer terrain. We need to tell the tool how much area you wanted to consider for the computation. So select that extent, click the area where I would like to have a, so that is the only region where the terrain will consider. If I have a big GPU, I could have considered even bigger area. This is running on my laptop. So now you can see, if you really want to see which all area going to be considered, you can enable this show extent. So you select extend tool, just select one more time that particular area and apply. Go to settings. Now I can see this is the area I'm going to do the computation. Rest of the other place, it's CAD is there, but we are not considering for the time being. And over there you can see the image of that product. Now go back here into your analysis. You can just run the analysis one more time. So it will run the GPU solver first, run for all 100 seconds. You can go to result. You will be able to see what time you ran and which time instance. For every 5 seconds image you can compute. Click on generate. You will be able to see those aircraft. Only aircraft is coming. You can see this range foldback is also happening because this is a spotlight SAR. If you If you want the SAR image to be always center, your distance to the sensor for all the time instant should be same. Otherwise, the range foldback will happen. You can export the video from these simulations. Now you can see this SAR image is getting created, but the problem is only one aircraft is visualizing, but our helicopter is not coming in. Let's debug why. What is the reason for it? So go back to. There is one more challenge. I'm pointing to. I should point to one of the aircraft rather than the um, Bangalore location. That is one. Now, second thing I need to check. Defining the launch, the computation axis or computation area. Scene object, I made a mistake. You can see C-130 instead of helicopter, I used a place. So I'm going to replace that with the facility, which is nothing but my helicopter. And another one is my helicopter and the C-130. So assign the, that's the reason the helicopter was not visualizing in the image. Now all are set. So run the simulation one more time. Analysis. So creating that extent one more time. Run the analysis. So make sure your objects are selected properly. So terrain, building, C-130, helicopter. These are the objects which is computed during this run. Once the simulation is computed, you can click generate plot. Now you can see helicopter is which start coming up. Helicopter is very small, and our range resolution and cross range resolutions are also is not that great. It's 0.5 meter. That's the reason it's not clearly visible, but you can still see the helicopter images is turning up. Now you can see this is a look angle towards the from the sensor to the location, especially to C-130, and your aircraft and helicopters are visualizing in the scenario. If you want, you can edit that the translucency and other thing. That's up to you.